Hello everyone, welcome back. In this video we're going to start learning about natural language processing. This is the type of machine learning that focuses on dealing with text data in particular. Our primary tool for doing this is we're going to start with something called the term document matrix. So here's the setup is we have a collection of documents. And so these could be like a bunch of different newspaper articles or a bunch of different books or something like that. Or they could be something shorter, like a bunch of different tweets. And what we're going to do is we're going to try to understand these documents by looking at which different words are in which different documents. So in our silly example, our documents are going to be very, very short. They're going to be they're going to each be one sentence long and, only like 5 or 6 words. So document 1 is the single sentence. This is the first one. Document 2 is the document. This one is the second one. And document 3 is this the first one? So what we do from this is we then make a matrix. And what we have is we have a column for each of the distinct words that appear in the entire set of documents. And it turns out there's only 6 of them. This is the first one and second. Those are the only words that appear. And in row 1, we have a 1 for each of the words that appear in the first sentence. And then there's a 0 because the word second doesn't appear in document number 1. In document 2, it's a similar story, except the word first does not appear, so that gets a 0. But the word 1 appears twice. Row 3 is identical to the first one because it has the exact same words as the first document, just happens to be in a different order. So this is how a term document matrix is constructed. And this was admittedly a silly example because what we'll see later is that more realistic example, the term document matrix is just going to be huge. But first, let's come up with ways to use Python to construct a term document matrix automatically. So one thing we could do is we could use for loops and be very creative, but this is going to be inefficient. And instead, we are going to use some pre-designed tools from scikit-learn. They're going to work a lot better. So to get started with, let's do our standard imports. Okay, import NumPy, import pandas from matplotlib, import pyplot as PLT. And in this video, we're going to need a new package, which we have not used yet, called NLTK, Natural Language Toolkit. And from nltk.corpus, we're going to import Gutenberg, which is a reader that's going to let us get a lot of different, very well-known books. It's a pre-designed package, which is going to be great. And we're most interested in the raw method of Gutenberg, which is going to give us the raw text of a bunch of great books. Our main exploration today is going to be focused on Alice in Wonderland, the famous book by Lewis Carroll. So we're going to say S is equal to Gutenberg.raw Carroll-Alice.text. And hopefully I spelled Lewis Carroll's name correctly. There are 2 R's and not 1. And it's a book. This book consists of many chapters. So what we're going to do is we're going to split the book up into a bunch of different chapters. And we're going to treat each of these chapters as its own documents. And as what we're going to see later on in this video, this is going to really increase our understanding of how the different chapters of the book are different. Certain characters will become more important early in the book. Some characters are more important later in the book. We're going to get lots of great insights. But so first, we're going to split it up into chapters. And so to do this, we're going to create a list called chapters using split. And, let's take a look at the first 500 letters of S. All right. Alice's Adventure in Wonderland by Lewis Carroll. Chapter 1, Down the Rabbit Hole. Alice was beginning. Okay, I'm not going to read the whole book to you. But it's a great book. I encourage you to read it. Okay. So what we notice from looking at this is that a new chapter starts with the word chapter in all caps. So we're going to use that as our splitter. And so we're going to say split on chapter, all caps, because we see it's all caps in there. And let's take a look. Okay, now let's look at chapters. Okay. So what we see is that before the start of chapter 1, there's just the title. In particular, chapter 0 is just Alice in Adventures in Wonderland number 1. And then chapter 1 is the actual first chapter, Down the Rabbit Hole. So what we're going to do is we're going to get rid of the text before chapter 1, and we're going to just start at chapter 1. And now let's see how many chapters are in the book. From what I recall reading this as a child, there was 12 of them, and it turns out that I was correct. Okay, so we're going to have to process these chapters and focus on the interesting words. We're not going to want to pay too much attention to punctuation or any sort of weird special characters. But it turns out that the Natural Language Toolkit has a ton of pre-designed tools which are going to be really, really helpful for doing all of this stuff. And the first thing for us to do is to put this into a data frame. So data frame is equal to pd.dataframe. And our data frame is going to have 2 columns. One is going to be called chapter. And chapters are going to go from 1 to 12. So we could say range, starting from 1, length of the list chapters plus 1. And then the other column is going to be the actual text of the chapters, which so we're going to use the list of chapters. So let's do this and take a look at a data frame. And as we can see, we got 2 columns. Chapter 1, Down the Rabbit Hole. Alice was beginning, blah, 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 blah. Chapter 9, The Mock Turtle Story. You can't, etc. All right. So now in order to process these things, we're going to grab the count vectorizer function from sk.learn feature extraction.text. So to do this, we're going to say, oops, I hit find and replace, from sklearn.feature extraction.text import count vectorizer. And the count vectorizer object is just going to be generally awesome, and it's going to help us do everything that we want. It's magic. It is a wonderful pre-designed tool that is just going to be a great big help for us. So we need to instantiate an object of this. So we're going to say vec is equal to count vectorizer. And we're going to want to introduce stop words because we want to filter out some super duper common words like he or she or the. And we're going to use the cut words which are super common in English. And then what we are going to do, stop words with a plural, is we are then going to use the fit transform method of the count vectorizer in order to create our word counts. So we say counts is equal to vec.fit transform. And we're going to want to apply this to the actual text of the chapters. And so we should be in business, and we mostly are, but there's a catch. So let's look at the type of counts. It's a sparse matrix. So sparse matrices aren't really something, matrices are really not something we've talked about in this course, but mathematically a sparse matrix is a matrix where most of the entries are 0. And this is usually going to be the case for term document matrices, so this is kind of smart. However, it's going to be harder for us to use it in this format, so let's go ahead and turn this to a NumPy array. So we're going to say counts is equal to counts dot to array. Alrighty. And now let's look at the type of counts. Oh, you can't run that code twice, so let's not do that. But now that we've run it once, let's look at the type of counts. Alrighty, it's a NumPy array just like we wanted. And now let's look at its shape. And now let's go ahead and look at the matrix itself. Okay, we can see that this really does kind of look like a sparse matrix. I'm seeing a lot of zeros. And this is starting to look good, but what would be even better is if we could turn this into a data frame. So to do this, we are going to use a count data frame is equal to pd.dataframe. And then we're going to use counts. And then we're going to label the columns. And the label of the column should be each of the words. And this is, again, where the count vectorizer is just straight up magic, is that we can use the get feature names method. And this is going to automatically get us the feature names that we want. And so now we get a data frame with all of the words that appear in Alice in Wonderland. And what we can see is that the word abide doesn't appear in the first chapter, but it does appear once in the second chapter. Absence only appears in chapter 8, and so forth. And now what we're going to do is we're going to concatenate this data frame with our original data frame using the concat method. So we're going to say data frame is equal to pd.concat. And we're going to say df, count df, axis equals 1. And now take a look at our data frame. Alrighty, so this is what it is. Here's chapter 1. Here's a count of how much the words all appear in chapter 1. And now let's try to learn something using this. So maybe let's try to see how important different characters are by chapters. So the main character of the book is Alice. So let's look at the data frame for the word Alice, or the column for the word Alice. We can see that Alice is mentioned 28 times in chapter 1, 52 times in chapter 8, and really she's mentioned quite a bit in all the chapters, which is, again, not too surprising because it is, after all, it's Alice's adventures in Wonderland. So now let's maybe make some plots for some of the other chapters. We've got Alice, we've got the Queen, who's an important character later in the book. We have her cat, Dina, and then we also have the Hatter. So let's make a plot. Fig x is equal to plt.subplots. And then for character and characters, x.plot df character label equal character. All right, this looks pretty good, but it would look a lot better if we had a legend. So I'm going to set the y limit first to be the y lim to be equal to 0 and none. And I'm also going to say x.legend. All right, and now we see that Alice is super important the whole book long. Dina kind of goes away after the early parts of the book. The Queen becomes more important, especially around chapter 7. The Hatter appears a lot around chapter 6 and then later in chapter 10. And really in this, using these very powerful tools that come in scikit-learn, we're able to learn a lot about this book. So we're going to continue more next time, but before we do that, let's do a brief digression. Right now we use the term document matrix that just counted how many times each word appeared in each chapter. What's actually more popular in some advanced applications is something called term frequency inverse document frequency, which somehow normalizes the terms of it. So here we're going to use TF-IDF, term frequency inverse document frequency vectorizer, in place of the count vectorizer. Other than that, everything's exactly the same. So let's go ahead and run this code. And we see we again get a sparse looking matrix, or a NumPy array that looks like a sparse matrix, I should say. But they're no longer integers. They're floats which estimate the weight or importance of a given word within a given document. And the exact mathematics of how this works are rather complicated. However, the two things to keep in mind from a qualitative perspective is a word is given a high weight in row n if it appears in document n a lot, which that's the same as with the count df, or if it appears there a lot but isn't common in all the other documents. So say document 1 had the word cat and platypus both appearing 3 times. I say the word cat a lot more than I say the word platypus. Well, I mean, I actually say the word platypus a lot because it's my favorite example when I teach programming classes for some reason. But for most people, cats are way more common. So if document 1 had 3 cats and 3 platypuses, it would be a lot more unusual and interesting that there was 3 platypuses. And so they would give a higher weight to the 3 platypuses than the 3 kitties. You don't have to worry about this too much, but this is a popular tool. So if you wind up using these methods in like a research project or something, it's something I wanted to make you aware of. Anyways, that's it for this video. I'll see you again next time.